Should we start? So welcome, everybody. My name is Uzair Qureshi. I'm from Intel Data Center Group. My other partner in crime is Petersen from Facebook. And I also have our partner, Choi from SK Telecom, as part of telling us how he's working with us, collaborating with us, and on these Lightning projects. So with that said,
all right, so today we're going to talk a little bit about the trends and challenges that we see in the storage world, a little bit about why we chose NVMe. Then we're going to go into Lightning design choices and some of the design challenges that we've run into. Then we'll talk a little bit about the current state of the PCIe and NVMe ecosystem. And then finally, we're going to hand it over to Alex to talk to us a little bit more about what SK Telecom is up to.
So like we all know, and you guys are IT managers basically, data is growing at tremendous pace. And it's actually doubling every other year. This basically brings challenges to you, the IT managers, of not only how to store the data, but how to effectively use the data as a competitive advantage. So which means more revenue for you, more opportunity. But the current infrastructures that you have, we call it legacy infrastructure, does not support that kind of workloads. And your DevOps people are continuously asking for new emerging workloads to provide low latency and high IOP kind of usages, and where the current infrastructure does not meet those demands. And then, and also they're looking at how we can have more agile and scalable systems that not only avoids the bottlenecks within the platform, but also provides you a balanced solution which gives you the better dollar per IOPS. So, so it's basically there's new set of storage infrastructure that's needed that is not meant by your current infrastructure. Chris.
PCI Express, or PCIe, is a flexible, robust, and widely adopted standard at this point. It also is a scalable interface, which means we can add or remove lanes to scale the interface as needed. It's also low latency and high bandwidth and directly connected to the CPU. NVMe, or NVM Express, builds on top of this. NVM Express is a lightweight and scalable interface. And in addition to that, it has the advantage that it's open source. The drivers are open, the management interface is open, which means we are able to contribute back to the community to overall improve the robustness and strength of the ecosystem.
So now, if you look at the, so if you look at the reasoning for NVMe, it's basically, if you're looking from a throughput, IOPS, and one more click, Chris, latency, hands down, NVMe is, I think, so you heard it from Jason Waxman's speech also, is 6x the performance of your, even the 12 gig SAS SSD. You're getting about double the half the latency as your 12 gig SAS SSDs. And so NVMe is definitely a scalable platform that provides the best throughput, IOPS, and latency to meet your emerging workload needs. And Chris, so what I wanted to ask you is, why did you guys, how did Lightning came about, and what made you evaluate NVMe as for the Lightning project?
So we wanted to take advantage of NVMe and PCIe and all the benefits that provides us. And the intent was we need to create a solution that allows us to scale IOPS per terabyte at an effective rate for us going forward. So to do that, we had to create a new type of JBOD, or a JBOF, just a bunch of flash, which we like to call Lightning. So in designing Lightning, we made several interesting design choices. First, we chose to make the design modular. So in this case, what that means is that we have the switches built on a separate board, and that allows us to implement different types of switch options or switch technologies. It also allows us to provides us basically with a simpler upgrade path in the future without having to redesign the entire infrastructure and the entire solution to get to that point. And finally, it gives us the ability to repair or replace the switchboard independently of the rest of the system. Secondly, we want to make sure the design is scalable and flexible. The design needs to be able to handle a lot of different types of applications and workloads. So to be able to do that, we have set it up such that we can change the number of external connections to different compute nodes. This basically allows us to dial in the compute to storage ratio so that it's ideal for a specific application. Third, we continue to try and build our designs to be highly serviceable. The ability to repair quickly and easily, especially with a toolless design, is very important to all of our designs. And then finally, we want to make sure that we have built-in flexibility in terms of the options for the SSDs themselves. So we specifically designed it so that we can support different SSD form factors. So we can support 2.5-inch, 3.5-inch, or even M.2 SSDs within the same platform, just changing different carriers that you populate within the system. This really allows us to select the right device for the right application at the right time. As part of the Lightning design, Intel and Facebook collaborated very closely and leveraged our existing storage expertise so that we could design, architect, tune, and build a solution that would work well. So I'd like to talk a little bit about some of the design challenges we ran into and kind of share those with the broader community. So first of all, one of the challenges with PCIe is hot add and hot removal of the SSDs themselves. Traditionally, this has been a rather complicated and error-prone process. Really what we want the system to look like is we want it to be seamless and transparent, just like any other SAS JBOD is today. The second challenge that we ran into is the management infrastructure. So the chassis management and system management infrastructure is still an evolving thing. So for us, we also don't have a local Ethernet connection into the chassis. So we had to work around that by designing the solution such that it worked through the compute nodes. The other benefit here that we chose to implement was we chose to build the management infrastructure around OpenBMC. Third, the other challenge we ran into is we had to design external PCIe cabling. Existing standards exist, but they are often difficult to work with and are not really optimal solutions. So we came up with and leveraged other existing standards like Mini-SAS HD external cables and added some additional sideband signaling for PCIe and management, and that way we can get to a cost-effective and scalable solution.
So, the other three choices, thanks Chris, so other three choices are the expansion and drive plane board. So how we divide the board up into is a PCI expansion board and drive plane board, sorry. So the way it was done is basically the reason for doing is as our switches are evolving, we wanted to provide the flexibility for customers to design their own switch module if they want to in their preferred switch without compromising and changing the design of the Lightning itself. So you can actually go and design another module to replace which we call as PEB, PCI Express expansion board, replace the front of the board, and with another switch vendor, as this, like I said, as the switch ecosystem is evolving, and use your preferred switch, and that will allow you to basically continue to benefit everything that you have with Lightning, but with a different switch module. So that's one of the choices that were made as part of that. The other part we actually looked at, since we were dealing with connectors and we wanted to basically do an end-to-end signal integrity testing to make sure that we met. And the reason why Lightning is very different from that perspective is we actually exceeded the limitations of what customers are asking, and we actually asked for a lot more for them to tweak, which minimized the cost. So retimers that were needed we actually try to drive as much cost effectiveness by basically by evaluating and going at much longer trace lengths, but we also did not compromise on signal integrity. So between Facebook and Intel, we worked continuously on tuning and tweaking the PHYs to make sure that we get the right amplifications to drive the data without compromising on signal integrity. And last and not the least is, I think so everybody, NVMe is evolving. It's a new technology. We are working through, together we are working with to see how we can get BIOS changes, driver changes in place, and there's still a bunch of bug fixes that not only we're doing in our BIOSes and drivers, but also working with our switch partners in hand to make sure that those are basically addressed. So from that point of view, we're trying to remove all the hurdles that you guys will look into doing when you're doing these kind of designs, and that is what is the major differences is between Lightning and other products that you will see, because we basically have made this a very modular and cost-optimized solution for you guys to adopt. Next slide, please. So I think so. As you can hear, Intel has been talking about PCI Express NVMe adoption for a while, and I think so. It's growing and it's growing strong. And with our contribution together with Facebook, we will be pushing this Lightning to the OCP, and we hope that with this will foster, which will increase the adoption of NVMe to the broader community at large. And as part of adoption, we have our partner, SK Telecom CTO, Alex Choi. He's going to talk about why and how he's leveraging the work we have done on Lightning and implementing as part of SK Telecom. Alex.
Thank you, Uzair and Chris. So you might wonder why the telecom guy is here this week. So for those of you who already attended the morning operator session, probably you get some ideas, but I will further explain why. So as properly addressed by these two gentlemen, so today's telco infrastructure is not scalable. They don't have a right cost structure. So going forward, moving to the next generation 5G, where we are thinking of launching this kind of innovative services to the end users, like massive data, AR, VR, 4K video, not just the download streaming, but also up streaming for the production, real-time production, and also all kinds of connectivity. I mean, the connected car and the massive IoT and the mission-critical IoT, where the latency is critically important. So just to meet these, newly emerging services, we have to be able to scale out our data centers. So the operators, our common practice is, used to be a very straightforward. We've just put together our wish list and then distribute out, and then procure the equipments from mainly the big vendors, not the small startups. So that's how things works so far. But going forward, we realize that it doesn't make sense. So we have to change it dramatically. So that motivated us to come here, to join and participate in the OCP, and especially, so that's mainly why I'm here. So, and next slide. So like I said, we definitely need, higher capacity and programmable, flexible, most importantly, scalable, without increasing too much TCO. So we are here to work together with all the ecosystem under OCP. So among them, future 5G data center or in general infrastructures comprise three things: computing, storage, and network. So As for the net storage, we are very much interested in all-flash NVMe JBUF. You know, we've done some research about what will be the key enabling technologies to make all this happen. So NVMe, we are so impressed with all the benefits of the NVMe promise. So we decided to go for the NVMe technologies and also PCIe, and we combine these two technologies together, and we will that enable us to build and architect our storage solutions for our future data center and giving us the maximum level of scalabilities. So on the left-hand side, we put together the 5G requirements for the storage infrastructures, and the higher IOPS, lower latency, and extremely low cost per gigabyte, and higher scalability, flexible, and you name it. So, and we internally launched some kind of a small project, prototyping project, where we built internally some kind of all-flash JBUF systems. And our initial target was shown on the right-hand side. For example, with the 1U size, 96 terabyte, and millions of IOPS, for example, the 10 millions of IOPS, and the hot swap support, and OpenBMC support, and et cetera. So, and then we realized that Intel and Facebook is doing a very interesting project called Lightning. So they've done so far excellent job putting together all these requirements and successfully developing the initial deliverables. So we discussed with the Facebook and Intel, and we decided to join. So that's why I'm here today. So we are really glad to be part of this wonderful joint projects, where so we have a very high expectation, and we really looking forward to see the real products, and I will definitely bring it to our data centers.
Yeah. So thanks, Alex.
Thank you.
As part of that, we, before we end for Q&A, I mean, all our booths have, Facebook's and Intel both has Lightning products running, and you can go and see how that it is. If you need to ask questions, there are people right on the side who will be able to answer those questions. So please feel free to stop at the booth and check out the effort we briefly discussed as part of it. We are open for questions if you have any.
Just to add on to that, so tomorrow, if you're interested in the nuts and bolts of the hardware design, I'm also leading a workshop in the storage track tomorrow. So if you want to learn a little bit more about some of the details, please come join the workshop tomorrow.
Thanks, Chris.
Sorry, there is no mic there. I stole it. I borrowed it, actually.
Can you tell us how you solve the problems of hot pluggability for PCI Express with the remote cabling? Or just give us an overview of how you're doing that?
Sure. So the reality is we're working through that right now. So the product is not final, so we're working through it. Actually, even this morning, we were working through some driver fixes on NVMe. All of those are going to get contributed back upstream. We're actually very close. I would say we're within a couple of weeks, maybe a month or two, before we have this really locked down. But so we're kind of working through some of that. Most of it, the reality is two parts. One is with the PCIe engineering change notice, or ECN, to add downstream port containment. That's one critical factor. So the switches that you use have to implement that. The second part of that is you need to have some driver work that has to happen in both the PCIe hot plug driver as well as the NVMe driver. That work is happening right now, and we're very close to having that done.
What about the electrical issues with PCIe plus devices coming and going?
Actually, we have not found any issues with that. The electrical side of hot plug for PCIe has actually worked reasonably well, and we have not found any problems with that, at least in our design.
And one refer to this as JBOF, just a bunch of flash. Would this approach be extensible to handle things like 3D crosspoint in the future?
Well, so 3D Crosspoint is certainly built to be able to use NVMe, so
Yeah, and
anything's possible.
that's a good part about NVMe because it's, the level of technologies, especially, if you look at Intel's portfolio, we have low endurance to high endurance devices with 3D crosspoints and low with 3D NAND. So that's where we talk about how you are scaling, you're looking for a new infrastructure because with a single interface you can scale from a capacity to more HA or lower latency aspects, and actually that will allow you to use one single interface for all usages you need. Yes, the answer is if people wants to use it, they can use it. There's nothing that prevents on Lightning that you can't use that stuff.
Thank you. Nice talk. What is the latency from the CPU to the devices? The flash devices.
You mean what's the added latency over PCIe?
Yeah, basically to access the devices. Like for example, like a DRAMs, it's probably in, sub 100 nanoseconds. What sort of latency are you getting?
Well, so the PCIe transaction level latency is, on the order of tens to hundreds of nanoseconds. Once you rebuild the entire packet, it's sub-microsecond levels.
Okay. Now, in terms of like let's say for example you have the search content, are those data kept in a DRAM, or are you planning to use this because you still have that's a significant latency from a CPU perspective versus for example if this was on a DRAM, accessible, content.
Sure. So speaking specifically for Facebook, we implement a tiered storage model, right?
Okay.
So depending on the type of data that we're talking about, or the temperature, if you will, of that data, it may move up or down in the stack. And as a side effect of that, we understand what the latency to access that data is and what the expected SLA is back to the user.
Okay,
So we can kind of move the data around.
So the NVMe, I guess at the bottom you probably have the coldest storage, and I guess I don't know how much you have the traditional storage, but then I guess it looks like NVMe is above it. But is there something above that, like that would be like some sort of a DRAM or where you keep the data?
Well, sure. I mean, if you want to look all the way up the
Yeah.
stack, above flash, there's DRAM, obviously.
Right,
And then
right.
the reality is you also have CPU caches as well.
Okay.
Right? So it really depends on. You really do have the full pyramid.
Okay. So are you leveraging, like for example, let's say if you are searching for something, is that data kept in a NVMe or is it kept in a DRAM?
Again, it kind of depends on the specific application. Search in itself is actually many applications for
Okay.
us. It's not a single
Right.
single
Application, right?
workload that's running.
Okay.
So each piece may be operated in a different portion of storage.
Okay. Thank you.
Like other software efforts that Facebook has done, is there any plans to open source any of the tiering software?
Actually, we do. So RocksDB, for example, is open source. That is designed specifically for tiered storage, as Jay Parikh mentioned a little bit earlier this morning. And that can work with all types of media. So it all depends on how you configure it, for example. That's just one example of a database engine that would work well with different tiers.
Okay, thank you.
So Jay also talked about something called MyRocks, which is a combination of MySQL and RocksDB. Can you talk a little bit more about it, and is it open sourced and on Git?
It is not yet open sourced. I believe at some point it may be, but I actually don't know the concrete plans for it at this point.
Any other questions?
Can you talk a little bit about the scalability aspect of it? Because the scalability is important. So if you're looking at 30 drives to one server, as you scale, you have to keep increasing the number of processors.
So I'll answer part of it and then
Yeah,
I'll let you.
go ahead.
Yeah, so the question basically was, can you talk a little bit about the scalability of the solution and how that works with different compute nodes, right? All right, so it's really about aligning the full resource pipeline, right? So you want to make sure that you have the right amount of flash capacity and the right amount of performance per terabyte, and make sure that your bottlenecks are all well aligned. So one of the ways that we're addressing that with Lightning is because we have the compute separate in its own machine, we can control the number of compute nodes that are connected to a given capacity of flash. And basically, we can reconfigure the switches to physically map different amounts of flash blocks to different amounts of compute. So that's kind of the high-level intent. I think these guys can probably talk a little more specifically about some potential applications for that.
So broadly, not necessarily just for Facebook, but I mean, if you look at it, you can make this a shared pool where, right now you're seeing 15 drives in a tray, 30 drives total. But like Chris mentioned, it can be taking a different form factor where you either bring M.2 or any other form factor that basically you can leverage on it. On top of that, the drive capacity is dramatically increasing in next 6 to 12 months, right? I mean, you're going from 4, 8, 16, and all whatever you want, right? So it's not about the number of drives you're connecting, it's number of storage you have accessible. And if you have a workload, because I think so, what Facebook's workload is not necessarily what you might be doing, but it all depends upon how your workloads is met through. Once we look at the latency of your workload, we can work out what that mix looks like. It can be higher, it can be lower, right? And but Lightning, with the question of Lightning, it's not only just. It can be a capacity storage, can be an HA, it can be a pool storage, however you want to use it. But don't think about that as a single, how many drives, but how much capacity you want to be able to, you can extract from it that meets your need, basically. So Alex, any thoughts on that?
All I can say is that scalability is the critically important, and yeah, I believe in these two guys.
Thank you, Alex.
Yes, sir.
Any plans for using Ethernet as the interconnect on Lightning?
So within the chassis, no, not at this point. We'll use Ethernet outside of the head node. We've talked a little bit in the past about disaggregating our infrastructure further. So right now, the compute that's connected to it, that could serve potentially as a head node, for example, and then distribute flash LUNs over the network, for example. That is one potential use case.
Yes, sir.
So you were talking about how many lanes you are running to the Lightning and PCI, and are you using the PCI switch in between? And how many ports you have, and what technology you're using for PCI switching?
All right, so there's up to 32 lanes coming in, and up to 60 lanes going downstream. They're all PCIe Gen 3. Naturally, to be able to do that, you need some form of switching topology. There's several different ways that you can implement that, depending on the capabilities of the switch supplier and the parts that you select. We have evaluated a couple of different options, but fundamentally, that's the basic topology.
And I think so when we mentioned that there's two boards. One is the PAB, which is the PCI Express expansion board. That's where the switch is there. So if you have a different need for a different switch, you can always swap that board out while keeping the Lightning as is. You just have to do the fine tuning based on the switch, and there are some changes that for hot plugs you might have to manage from a switch vendor to switch vendor. But basically, from a hardware point of view, that's the board you need to change to be able to leverage another switch.
Okay, thank you. Another question is about the namespaces. Are you pooling the namespaces to present as one big LUN to the compute node, or you have different namespaces, and every namespace is to be presented to the compute node and be pooled by the object storage itself?
Sure. So the hardware itself just presents the physical block devices, right? So it's up to whatever storage layer that you want to run on that head node to decide either if you run a storage layer there at all, or just use physical devices, or if you want to pool those further. So I think there's a couple of different directions that you can go. The design doesn't preclude any one of them. So you can pool it, you can directly connect to it and use the devices directly. Any of them are options.
So in that case, your RockDB software will be running on the head node as well?
That is a possibility.
That's it.
So guys, I think we're out of time, but please feel free to come grab us afterwards if you have any more questions. Thank you.
Thank you. Thanks, Chris.